All right, guys, moving on. Um, Sorry to interrupt. You guys can have breaks to chat. The the next thing that we need to do here is basically set up a point to measure the relative location of all the other points from. And it's really just to establish a proportional relationship from your center point or attractor to everything else. So the tool that we're going to need, that's kind of our key, is called closest point. And it's under the vector panel, under the point, or the vector tab under the point panel. And it's right here, it's called closest point. Might be points. I always get them backwards. I believe it's closest point. So closest point asks for a point to search from and a cloud of points to search. So what this means is that it's going to basically just measure a proportional list, like I said, from one point to a list of points. And then we can take that distance value, right? It's a list of variable magnitudes. And as long as we have the same number of variable magnitudes as we have modification values or indices, then it'll match up and we'll be able to apply it, basically. So let's take a look at what that looks like. The points as a tree, and this is the part that gets kind of counterintuitive because point is singular. Cloud of points is plural. However, we are actually putting in a tree or a list of points into that input. So I'm going to go down here and go to the points to search from, so my point output from the grid. The other thing that we need to do is to make sure that all of these values are being mapped properly. This entire list should be flattened. So now we've got a list of 66 individual points that are being read one by one. And based on what we learned on Tuesday, you should be able to visualize in your mind what that means. So the other thing we're going to do is drop a point into the Rhino workspace. And this is going to be our magnet or our attractor point, which will determine where our pattern is either going to scale the squares up or scale the squares down. So I'm just going to start off by putting one right in the middle-ish. And I'll go into Grasshopper and reference it in. So grab a point from the params menu and then set one point and select it. And of course, naturally, this singular point is going to go into the cloud as a list right here. So let's take a look at the numerical values we have. What we get are a bunch of values, 30, 25, 18. Basically, it's an entirely different list of 66 different magnitude values, distances. We also have the CP index, which doesn't really matter for us right now, and the points also can be fed out as another list again, but we don't need that right now. What we do need is the distance. We're going to use this to remap a new list of modifications. Okay, so what we're doing, like I mentioned a second ago, is scaling. And so I'm going to go up into transform and affine, and I'm going to scale this geometry based off of the list of magnitudes that I just created. Whoops. Let's see, this is vector, point. This is transform. Whoops. Okay, so remember, the scaling factor here is numerical. Okay, so I'm going to show you real quick how do you manage the size of this list to make it match the type of scale that we want to scale to. But just real quick, I want to make sure that you guys are still keeping up with me at this point. Do I need to pause for a little bit, or you guys are okay? You're okay? All right, cool. Awesome. You guys are getting better at this. All right, so moving right along then. The key here is the remap node. That's found under math, domain, remap numbers. And I need you guys to pay extra close special attention to this one. As I explain it. So remap domain, it says it remaps numbers into a new numeric domain. Okay, so it's going to ask for a value to remap. Then it'll ask for the source domain. And then it'll ask for a target domain. Okay, so the way that I described a domain to you guys in the past was how? A limit, right? Or in other words, a boundary. Okay, so the target domain, notice it says 0 to 1. And the source domain says 0 to 1. So until we tell it what source domain we're trying to use, right? So what's my minimum and maximum? And then we tell it what we want it to then shrink down proportionally to become, then it's just going to have this default. So essentially what we're doing is we're taking this list of values that goes anywhere from, less than 1 to 30 feet, and we're going to say, I want to take these in proportion to one another, and I want to shrink it down to maybe 0 to 2. So that way, we're saying, I want the point on this grid, let me move this a little further away. So the rectangle that's farthest away is going to scale the most. And that maximum value is going to be 2. So let's do that now. And essentially the value to remap really is just asking for your list of numbers. And that would be the D right here. And then you have to create your domains. So the source domain is going to take the minimum and maximum value of your list, which can be done by going under math and domain and bounds. It creates a domain which encompasses a list of numbers, is what it says. So you plug your numbers in, and what you get is a locally defined value from 1.6 to 37.1. That's what we plug into the source domain. And now what you see, before I give it a new target domain, that list of numbers has shrunk down proportionally to a range of 0 to 1. Additionally, we now have to override the target domain with a new one that we determine. So you can go to math and domain, and sorry, not that. Go to construct domain, plug that in, and we'll use panels under params, and we can just determine what it's going to be. So if I want my smallest rectangle to scale down to a size of 1/4 its original size, I'll start with 0.25. And if I want my largest rectangle to be twice its original size, I'll scale it to 2. Plug that into B, plug this into A, and now we're pretty much off to the races. We have the scale factors are pretty simple. The geometry is going to be the rectangles themselves. The center points is going to be the list of points. And then the scale factor is going to be your newly remapped list of numbers. So I'll plug that in here. And once you turn off the rest of this stuff, you'll see how it works. Pretty cool, right? The definition bigger?
Yes.
Yeah, of course. So real quick though, I just want to point out to kind of close the thought on the initial idea of attractors. This is fully parametric. As your geometry changes, so too does the the grasshopper definition as well. So if I move my attractor to the top end, that all scales properly. If I move it down to the middle, everything else scales relative. If I move it down to the bottom, it'll scale towards the top. What questions do you have? Did I just hear so cool? All right. That's the ticket. It really is Cinco de Mayo, I guess. All right, I'm going to come help you guys out.